Welcome to Power's channel, and this video I will talk about we will build a small tiny STEM AI agent with LangGraph. In previous video I will talk about how we can create a STEM AI agent using LangChain, and I will give some comparison and difference between LangGraph and LangChain, and how you build better way or your agentic system with LangGraph. So, let's start now. LangGraph. So, based on the name, something we will build with the graph design. Like here, it will come some node, some essays at all. Okay, so we'll take one example that is for implementation purpose, like small AI agent, small STEM AI agent. So in this STEM AI agent, it will perform basically two tasks. One is it will explain whatever question asked by the student. Second is it will some do calculation if asked any calculative questions. So here we'll create two tasks. In the previous example also, in LangChain also, same application that we created LangChain, we'll create with the LangGraph. So what would be the flow here? Flow would be, okay, just imagine student come to a agent and ask some questions. What is the temperature in the metal? How resistance and temperature vary? If student asks some calculative questions, then might be a calculation question. So you just imagine, and just imagine that you are building a AI agent with the LangGraph. Then you will create a router node here. Router node will decide the particular task, which code related to first one explanation, second is calculator. if you're building with LangGraph, then it will go for a different node. So each task by each node, like okay, then it will go for whenever it, like you ask to user particular explanation task, then it will go to explanation node. Second, if you ask a calculative task, then it will go to calculator node. And finally I will create a final router node, then it would answer final answer. So now let's build a small tiny agent like STEM agent. Okay, so for this first step, like we'll install LangGraph. We'll like pip install whatever library you're using. So we install it. Second is we need a LLM. If you have OpenAPI, then just use OpenAPI key and run it. And if you have already hosted your LLM, your local machine, yeah, you hosted somewhere, you just pass your local host. If you want to do with Olama, then I just added this already script how you can download Olama and just pull this coin to 0.5 billion parameter. So why I choose this coin 2:0.5 B, because of it can run on 2 GB RAM. So for testing and educative purpose, that is very fine. We don't want to go beyond high level, but if you want really a STEM agent, then definitely you need STEM context aware good model that you can use enterprises or whatever. But anyway, but if you able to bend this tiny agentic system, then you can build any big one also. Okay, then let's start one by one. So first is, okay, so what would advantage of LangGraph? Like it's manage the state. So we'll create this state class, and this state class uh, is a base class used by whatever node we'll create later. So the first step of LangGraph will create the state class. So state class will use your questions and what lateral type, like question type, okay, explain and calculator, and answer would be a string, int, whatever available, you just define it this class, and this state maintained for each node. Example will go for the next node. Okay, so now we'll create a what need to be decided. So this is decide what to do. It's like agent here, agent would decide, okay, we'll do a explainable task or AI calculative task. So we'll create a router node here. So if router node will decide it is explainable task or AI calculative. So two tasks, explain and calculate, whenever it will decide. So in the previous example, okay, in the LangChain, if we compare it, so here we create a node and we are passing this state always here. So state is maintained in this node also, and LLM invoke here, and this one. If we go back to the LangChain same code, where this step we just create a router chain for it will decide, and we create a chaining prompt here, like prompt LLM then output. Here we are creating a node which invoke the LLM and it will give the result type. Okay, then this router node decide which task need to be performed, and then it will go based on, then if user ask explanation task, then it will go to explanation node. Then this state also pass here, state is question, and LLM invoke here, it will return the answer explainable, whatever question asked to the user. If is calculative, then definitely this node will go for calculative. Finally here build a LangGraph. So you have all three nodes, one is router node, one is explanation node, one is calculation node, and finally we build here the graph. So okay, then stage graph call here, state is passed, graph we are adding this all the node, and set entry point is definitely router, and then conditional means which and not need to be decide. Then if explanation need explanation, so data flow will go for explanation, yeah, calculative. So that is the conditional edge we are adding, and that is the power of, like, you can create a conditional edge here, and based on the conditional edge, you know which node you will to traverse, it will traverse based on that. And finally end would be your, you are adding the edge node also. So finally definitely you need to add all the edges and all the nodes, then only your graph is completed. And you compile this graph, now graph is available. Okay, now finally we'll go, like finally we'll run this agent. Okay, so student come to the agentic application here, this same agent ask what is the temperature, why does increased temperature increase resistance in the matter, then it will answer the question. So this is the flow of LangGraph. I think if you compare apple by apple, then here we are creating the node, and we build graph here, but LangChain we rather than create, rather we are creating each chain of whatever task we created. So for router chain, we created router node for LangGraph. Explanation chain, we create explanation node for LangGraph. Calculator chain for calculator node for LangGraph. Then manual routing logic we written here, where we are first we invoke the chain, then decide by calculation chain, then explanation chain, then we call runnable. So finally, this router we pass to runnable. Whenever runnable is run, then we'll get step agent and question will ask. So for this manual routing logic, here we build a graph structure here. We added node, we created edges. One is end conditional edge for decide condition, then final end node edges is explanation and calculative, and then compile the graph. And finally, STEM agent is ready. User, student can ask any question to this. So this is the final one. LangGraph agent is ready. STEM agent is ready. If you want to add more node, more tasks, and more, we want to add any conditional, then add any whatever condition you want to do in the edge. So that's why we call as a conditional edge. So conditional edge is very important here. If any decision making tasks, which tasks need to be performed, is not to be performed, that all go to the conditional edge, and final normal edge is there just as the add edge, that would be might be a AND edge, any chaining edge also. So LangGraph built on top of the LangChain. So LangChain is baseline. Top of LangChain you can build LangGraph. So both. So if you use both LangGraph and LangChain, then you could build a powerful agentic framework, agentic application using this powerful agentic framework. So that's all about LangChain and LangGraph. We did comparison. We built tiny small agent also with like as a STEM agent. How can you use? I think this is the fundamental. And if you add more and more complex structure you will create, then again you have to create a graph, build it, run it, check it. So that's all about whatever application you are building. So that's all about this video. Thank you so much for this watching. If you like it, then definitely you click on the like, and thank you so much.